Family meals, a place to connect and exchange love, now hide a silent worry. Tiny plastic particles, also known as microplastics, may have infiltrated our plates without anyone knowing. From ready-to-eat crispy fried shrimp to raw oysters served with tangy lemon at the dining table, many familiar seafood types are being found to contain high levels of microplastics. International media reports and numerous scientific studies in recent years have shocked the public. Plastic pollution is no longer a distant ocean problem. It has entered our food from the sea to the dining table. In today's video, let's explore what microplastics are and two familiar, delicious seafood types that potentially harbor microplastic contamination. What are microplastics? Why are they not just trash? Microplastics are very small plastic fragments, usually defined as less than 5 millimeters in size. They are divided into two main groups: primary microplastics, plastics manufactured at a small size, such as microbeads in cosmetics, microfibers from synthetic clothing, and secondary microplastics, fragments from the breakdown of packaging, fishing nets, plastic pipes, household items. These particles can float on the water surface, mix into marine sediments, or absorb toxic chemicals from the environment. Characteristics that make microplastics a serious problem. 1. Their small size makes them easily mistaken for food by marine organisms, from bacteria and plankton to fish, shrimp, and mollusks. The surface of microplastics easily adheres to harmful chemicals, synthetic plastic compounds, additives like phthalates, bisphenol A, and pathogenic microorganisms. Microplastics can move along the food chain, from plankton to small fish, then to larger fish or animals consumed by humans. Thus, microplastics are not just trash floating offshore. They are physical and chemical particles that can directly interact with organisms and humans. In recent years, many reports and studies have revealed the widespread presence of microplastics in food. An international media report, CNN 2024, stated that up to 90% of tested animal and plant protein samples contained microplastics, a figure that has drawn public attention due to the broad scope of the issue. More in-depth studies have also found microplastics in many seafood species: shrimp, oysters, mussels, squid, sardines. A study published in the journal Environmental Research revealed a shocking fact: battered fried shrimp, a popular processed food, can contain on average more than 300 plastic fragments per serving. This is not only because shrimp ingest microplastics, but also because processing, batter coating, and plastic packaging contribute to retaining and adding these particles. Researchers from the University of Hull, UK, and works such as those by Professor Francisca Ribeiro, University of Queensland 2020, also showed that oysters and filter-feeding mollusks, mussels, clams, scallops, have much higher microplastic densities per gram of tissue compared to some crustaceans or fish. Other expert reports emphasize that just 300 grams of fish meat, like grouper, catfish, or snakehead fish, can contain hundreds of microplastic particles, which is alarming because a typical family fish portion can easily reach that amount. Importantly, studies show that microplastic levels in seafood do not differ significantly from those in terrestrial meat: chicken, pork, beef. This indicates that microplastic pollution has spread widely throughout the global food chain. Why do shrimp and oysters lead the contamination list? 1. Shrimp, a microplastic reservoir due to diet and farming cycle. Shrimp feed on plankton, organic detritus, and suspended particles in the water, precisely where microplastics accumulate. Both wild and farmed shrimp easily ingest microplastics. Additionally, processing and preservation using plastic packaging, plastic bags, or plastic equipment can increase microplastic exposure to the product. Farmed shrimp in ponds may be contaminated from industrial feed, which may contain water or ingredients contaminated with microplastics, pond bottom sediments, and pumped water. Wild-caught shrimp are directly exposed to water currents carrying microplastics and contaminated plankton. Processing, battering, frying, creates an environment for small particles to adhere to the batter surface, and packaging and transportation with plastic materials can increase microplastic content in the final portion. Therefore, it is not surprising that some studies found huge amounts of microplastics in battered shrimp, clearly showing that handling and packaging also play important roles. 2. Oysters and filter-feeding mollusks. Sea filters. Oysters, mussels, and clams are filter feeders. They draw water through their bodies to capture plankton as food, inadvertently filtering suspended particles in the water, including microplastics. Because they accumulate particles per unit of tissue mass, the microplastic density per gram can be very high. Some features make oysters prone to heavy contamination. Lifestyle. They filter large volumes of water continuously, increasing the chance of microplastic intake. Physiology. Some particles are retained in tissues and not quickly expelled. Harvesting areas. Oysters harvested near urban areas, river mouths, or regions with industrial farming activities, and waste discharge often have higher contamination levels. Because oysters are often eaten whole, sometimes raw, the risk of microplastic exposure cannot be eliminated by simply washing the surface. How do microplastics affect health? Currently, the scientific community is still gathering data to clearly assess the human health risks posed by microplastics. However, there are several concerning mechanisms. 1. Mechanical effects. Ultra-small particles can cause irritation and inflammation in tissues if accumulated or penetrating the intestinal wall. Some animal model studies have observed inflammatory responses at high doses. 2. Carriers of toxic chemicals. Microplastics may contain plastic additives to enhance flexibility, durability, and absorb environmental pollutants, aromatic hydrocarbons, heavy metals. Once inside the body, these chemicals can interact with tissues, affecting endocrine and immune systems. 3. Microfibers and very small entities. Synthetic fibers, from clothing, differ in shape from round fragments, easily adhering to tissues and causing different reactions. 4. Pathogens on surfaces. Microplastics can harbor bacteria and viruses, increasing the risk of disease transmission when consuming contaminated food. Importantly, most current conclusions are precautionary. There is no clear evidence that microplastics at normal dietary levels directly cause severe diseases immediately. However, the consequences of repeated exposure, accumulation over time, or combined effects with other factors, environmental toxins, immune disorders, remain concerning and require further research. Practical ways to reduce microplastic exposure in meals. Here are specific, easy-to-implement measures for each family, combining food selection habits and changes in preparation and storage. Before buying, choose clear sources. Prioritize seafood harvested or farmed from licensed areas with transparent labeling about origin. Ask sellers about harvesting areas and farming methods. Limit processed foods. Battered industrially processed foods, e.g., packaged fried shrimp, frozen seafood with multiple layers of wrapping, often have higher microplastic risks due to processing and packaging. Diversify foods. Avoid relying on a single seafood type. Alternate between fish, other seafood, and plant protein sources to reduce accumulation risks. During preparation, wash thoroughly. For shellfish like shrimp and crab, rinse under running water to remove particles on surfaces and shell crevices. For oysters, mussels, cleaning the outer shell reduces dust/debris but cannot remove microplastics already inside tissues. Clean intestines. For shrimp, removing the digestive tract eliminates most residues in the gut, where larger particles may be present. However, evidence shows some microplastics may be in the flesh, not just the digestive tract. Oxytocin. Limit raw consumption. Oysters and some mollusks are often eaten raw. If concerned, prioritize thorough cooking. High heat does not eliminate microplastics, but can reduce bacteria and viruses. Avoid industrial battered fried foods. Batter coatings and processing tend to retain or add microplastic particles. Homemade cooking with fresh ingredients and minimal packaging is safer in this regard. Storage and serving. Reduce plastic packaging. When buying, prioritize products packaged in paper or recyclable materials. At home, use glass balls, metal containers instead of nylon bags. Avoid heating in plastic. Do not microwave food in plastic containers, as heat can release small plastic components. Microplastics are widespread, but we can minimize risks by smart choices in selection and preparation. 1. Shrimp and oysters are two seafood groups to watch. Shrimp because of their plankton diet and processing methods. Oysters because their filter feeding concentrates microplastics, but many other seafood types can also be contaminated. 2. Cooking thoroughly, washing well, prioritizing fresh foods, and reducing plastic packaging are practical, easy, and immediately effective steps. 3. Do not panic, but do not ignore the issue. Apply the precautionary principle, reduce unnecessary exposure, maintain a diverse diet, and be vigilant about food origins. Microplastics are no longer a distant ocean problem. They have infiltrated our daily meals. Although science continues to clarify the exact health risks, current evidence is enough for us to change consumption habits cautiously and responsibly. The Everyday Life channel will continue to accompany you with close-to-life, practical content to protect the health of your whole family. If you find this video useful, please subscribe to the channel and hit the bell to not miss future videos. Wishing you success and good health. Let's join Everyday Life in caring for every meal and cherishing the health of every family member.